Hello everyone, in this video let's discuss the BFS algorithm in the ununiform searching technique in artificial intelligence and machine learning. If you see here, what is BFS? BFS means breadth first search algorithm. So here under ununiform searching technique we will be having two. First one will be DFS and second one will be BFS. So this is the second one. So DFS video link is given in description, you can access it. Now if you see, this ununiform searching technique will not have the domain specific knowledge. So what it means? If you see, this A node will be having its own information and the information of its child, that is B and C. After that it will not have the information of all the nodes. So you can tell it as not a domain specific knowledge. Now if you see the properties of the BFS, that is breadth first search algorithm. Breadth first search algorithm. So what it tells is it uses FIFO in Q data structure. So it will be using the Q data structure and it will be following the FIFO algorithm. What is FIFO? First in, first out. So who will be entering the queue first, they will be kicked out or removed from the queue first, like that. So I will show in the question. Now second one is it gives the optimal result or optimal cost is given. So if you see, BFS will give the optimal solution, but DFS will not give the optimal solution. Here the complete answer will be given. That is only one answer will be for, that is only one answer will be there for the question which will be given. But in DFS we can have more than one answers. Now if we see the time complexity, so if we see in the data structures and algorithm, how we will represent order of V plus E. V means vertices. E, G, all are there, no? They will be called as the vertices. Plus E means edges. So two vertices will be connected using a line called as edge. So they will form the relationship between the two vertices or nodes. Now if we see in the perspective of the artificial intelligence and machine learning, it will be of order of B power D. B means the branching factor and D means the depth of the tree or the graph you are using. So here let us consider this question and solve it using the BFS searching algorithm. So what it will be using? It will be using the Q. So to solve, we can form the node list. We can form the node list or we can solve it using the Q. But in the artificial intelligence and machine learning, most of the exams they will ask to solve it using the node list itself. So what we must do? We must mark the level. So this is level 0, level 1, level 2, level 3 and level 4. So level will start from 0 and it will go as deep as possible. Now level by level, left to right. In BFS what is the funda you must follow? Level by level, that is upside to downside. Level by level, left side to right side. Level by level, up left side to right side. So node list at the starting at the 0th level. If you see at 0th level, I am having only one node, that is A. I am having one node. So what I will be doing? I will be expanding that node. Now my node list will be updated. I must not write A, I must write its child. So what are its child? B and C. So you must write B first, then you must write C. Why? Upside to downside, left side to right side. Upside to downside, left side to right side. First at the left we will be encountering B, later we will be encountering C. Now what I will be doing? I will be expanding B because B came first. First in, first out. B came first. So we must update the node list. I am expanding B. What is the leftover nodes? C is left as it is. First you must write the leftover nodes, then you must expand B. So if you expand B, what are its child? D and E. First you must write D, then you must write E because upside to downside, left side to right side. Now I am having C. I will be expanding C so that I will be updating my node list. First I will write the leftover nodes in the queue, then I will write the branching of C. If you see, C is having two child, that is D and G. D and G. G is my goal state, that G is my goal state to which I want to move. So when I encounter G and pop it out from the node list or the queue, so the problem will be end. Now I will be expanding D, so I must update the node list. What are my leftover edges or the what are my leftover vertices or nodes? E, D, G is left. I want to branch D. D is here. So D is having two child. First you must write C, later you must write F. Upside to downside, left side to right side. Now you will be expanding E. So node list will be updated again. First you must write the leftover elements, that is D, G, C, F. Now you expand E, but E is not having any child. It is a leaf node. Leaf node means no child. So you will leave as it is. Then you will be expanding D. If you expand D, again you must update the node list in every step. G, C, F will be left as it is. Now expand D means it is having two child, B and F. So B will be written first, later F will be written, since upside to downside, left side to right side. Now I must expand G. That is, I will be kicking out the G from my queue or node list because it is the first one to come. First in, first out. If I remove G, what is the leftover element? C, F, B, F will be left. Now I don't want to expand G. Now I don't want to expand G because I took it out from the queue and it is the goal state which I want to move from the initial state A. So I reached my goal state. Therefore, you can write we reached goal state. We reached the goal state G. So this ends the question. So what you will be doing? You will be updating the node list in each and every step, and who will be at the starting of the node list, you will be expanding them, and all others will be written first. Then you must expand the first one who will be kicked out from the queue or the node list first. So hope you understood the concept of the BFS, that is breadth first search algorithm, and how to solve the problem related to it. The DFS algorithm problem is given in description. You can access it. If you have any doubt regarding this topic, please do comment below. I will clarify it. If you liked the video, please do subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.